We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello friends, today we are discussing about vapor absorption refrigeration systems. We already know that there are so many types of refrigeration systems are available in the world. Okay, so in our as per GTU syllabus, there are 3 types of refrigeration systems are available. First is air refrigeration system, second one is vapor compression refrigeration system, and third one is vapor absorption refrigeration system. Air refrigeration system, which is uh, working on the basis of air as a refrigerant. Vapor compression and vapor absorption refrigeration systems are working on the basis of different refrigerants are available and as per the evaporator temperature requirement. Okay, so it is working on the basis of applications. Okay, so vapor absorption refrigeration systems and vapor compression refrigeration systems are very similar with each other. We already know that vapor compression refrigeration system having a 4 main components: compressor, condenser, expansion valve and evaporator. And vapor absorption refrigeration system, out of these 4 components, 3 components are common. First is condenser, then expansion valve and evaporator. Only one part is different from vapor compression refrigeration system. Compressor is replaced here with the absorber generator mechanism. Now we are discussing about simple aqua ammonia cycle. Simple aqua ammonia, aqua means water, so simple water ammonia cycle. Here two different uh, we can say fluids are used. Okay, one is water and second one is ammonia. Generally in a vapor compression refrigeration cycle, only one fluid or one refrigerant is used. Okay, here two fluid, out of these two fluid, one is refrigerant and second one is a absorbent. Okay, so here we already discussed with you 4 main component of vapor compression refrigeration system. Out of this 4 component, left hand side 3 components are same: condenser, expansion valve and evaporator. Right hand side dotted line box, which is indicating the additional mechanism which is known as the absorber generator mechanism, which is replaced with the compressor from the vapor compression refrigeration cycle. Okay, now we already know that at the exit of the evaporator we are getting low pressure low temperature vapor refrigerant. So here ammonia is a refrigerant and water is a absorbent. That's why at the end of the evaporator we are getting low pressure low temperature vapor ammonia. When this low pressure low temperature vapor ammonia is enter inside the absorber, absorber is totally filled with the water. That's water having a low temperature, because at low temperature of the water having a higher affinity to absorb vapor ammonia. Around 12 to 13 degrees Celsius temperature of the water, uh, uh, ammonia vapor is highest absorbed inside it. It is 3 times the volume of the water. Means if 1 meter cube of water is available in the absorber, then it can absorb 3 meter cube of vapor ammonia inside it at 12 to 13 degrees Celsius. So we maximum try to maintain the temperature of the absorber around 12 to 13 degrees Celsius. Now these mixers which contain maximum ammonia and minimum water, which is known as a rich mixer. Okay, this rich mixer is passing through the liquid pump and one heat exchanger to the generator. Now we know that at the exit of the evaporator we are getting low pressure low temperature vapor ammonia, and at the entry of the condenser we already know that we must be require high pressure high temperature vapor ammonia. So we have to convert this low pressure low temperature vapor ammonia to the high pressure high temperature vapor ammonia through this absorber generator mechanism. Okay, so this absorber generator mechanism, how it convert this low pressure low temperature vapor ammonia to high pressure high temperature vapor ammonia. So first of all, low pressure low temperature vapor ammonia mix with the water inside the absorber, which generate rich mixtures. Now this rich mixture is passing through the pump to the liquid heat exchanger, liquid pump to the heat exchanger to the generator. Generally we have to maintain the absorber temperature around 12 to 13 degrees Celsius, because at the temperature we are getting maximum absorption. Now what is the temperature of the generator? We have to maintain the temperature around 77 to 83 degrees Celsius. So at that temperature ammonia is separated from the water, and it is converted into the high pressure high temperature vapor ammonia. Now this high pressure high temperature vapor ammonia is passing to the condenser. So condenser is the device which is one type of heat exchanger, or we can say phase conversion type of heat exchanger. So only latent heat is removed during this process, so pressure and temperature is remains constant. So at the end of the condenser we are getting uh, high pressure high temperature liquid ammonia. Now this high pressure high temperature liquid ammonia passing through the expansion valve. Expansion valve is the device which is used to reduce the pressure and temperature of the refrigerant. So when uh, high pressure high temperature liquid ammonia passing through this expansion device, it is converted into the low pressure low temperature liquid ammonia at the end of the expansion device. Now this low pressure low temperature liquid ammonia is enter inside the evaporator. So we already know that evaporator is the device. It is also having a one type of latent heat exchanger, means it is used to convert the phase only. So evaporator is the device which will absorb the heat of the surrounding of heat in form of latent heat of refrigerant. So refrigerant is converted into the vapor and cooling effect is generated, or we can say refrigerant effect is generated in the evaporator space. Now this low pressure low temperature vapor ammonia is enter inside the absorber and process is continuous going on. Now we already discussed whole process, but still one process is remaining, heat exchanging process. So in generator generally 77 to 83 degree temperature is maintained. At that temperature we cannot separate 100% of vapor ammonia. We can separate maximum 88% of vapor ammonia from the water in generating process. So remaining 12 percentage of vapor ammonia mixed with the water at the end of the generating process, which is known as a lean mixers. Now this lean mixers is passing through the heat exchanger to reducing valve to absorber. Now here reducing valve is used to reduce the pressure. When we reduce the pressure, temperature will automatically reduce. So we are getting low pressure low temperature lean mixers at the end, at the entry of the absorber. And heat exchanger having a main purpose is that uh, lean mixers suppose having a higher temperature, it is heat exchanging with the rich mixers having a lower temperature. So preheating of rich mixers is taking place and cooling of the lean mixers is taking place. So uh, less amount of heat is required in generator, as well as less amount of pressure reduction is taking place during reducing valve. So it is the main purpose of providing heat exchanger. So this is simple aqua ammonia type of cycle. Now we are discussing about second type of cycle, which is known as a practical aqua ammonia cycle. Now practical aqua ammonia cycle is very similar with the simple aqua ammonia cycle. Only two components are added here. One is analyzer and second one is rectifier. Now why these two devices are added with the simple AQUA-AMMONIA cycle? Remaining all part are same, remaining whole process are same, but first one simple AQUA-AMMONIA cycle, which is not practical one, it is just one type of theoretical like a Carnot cycle, and second one is practical AQUA-AMMONIA, is known as a practical cycle, and it can be used by you, or it can be used in a very well known industries where its application are available. Now first of all we are discussing about why analyzer and rectifier are used. First thing is that at the end of the generating process, we know that high pressure high temperature vapor ammonia is separated from the water in the generator. So sometimes around 2 to 5 percentage of water vapor particle mix with the high pressure high temperature vapor ammonia, which is enter inside the condenser. Okay, when it is enter inside the condenser, it will be condensed. Okay, when it is condensed there is no problem, but when it will be passing through the expansion device, so in expansion device we already know that it is the function to reduce the pressure and temperature. So if its temperature is below 0 degree or at 0 degree Celsius, then water particle will be freeze inside the expansion wall. When it will be freeze, it will be choke the flow of the refrigerant, so it will create a very big problem inside the cycle. That's why we have to take care about that. We cannot pass single particle of water vapor inside the condenser. If it will not passing through the condenser, it will not passing through whole cycle, so we have to make sure about it. We cannot pass a single particle of vapor ammonia. So here first of all strong solution or rich mixers we are discussing about it, which is passing through first of all analyzer. Analyzer is one type of perforated tray type of device. When it will be passing through this perforated tray, some heat exchanging is taking place between uh, vapor ammonia which is coming out from the generator and a strong solution. So strong solution is preheated, as well as some vapor ammonia which is coming out, high pressure high temperature vapor ammonia coming out from the generator. Heat exchanging or surface heat exchanging is taking place. So suppose any single particle of liquid sorry a vapor of water is mixed with this high pressure high temperature vapor ammonia, which is separate out here. Okay, if still it is not separate out, then it will be passing through the rectifier. In rectifier cooling process is taking place. You can see that cooling water is passing. So cooling water is passing, so cooling water will be condensed the water vapor particle. So 100% of water vapor particle is separate out during this analyzer rectifier process. Remaining all these process are same. Means first of all from evaporator outlet we are getting low pressure low temperature vapor ammonia, which is absorbed inside the water inside the absorber at 12 to 13 degrees Celsius. It will be passing to the generator. Here they are not passing directly to the generator. First of all it will be passed to the analyzer for surface heat exchanging, then it will be passing to the generator. Generator is the device in which temperature is maintained around 77 to 83 degrees Celsius, so it will be separate vapor ammonia, high pressure high temperature vapor ammonia. Now this analyzer and generator outlet. Okay, generator outlet, high pressure high temperature vapor ammonia and strong solution heat exchanging is taking place. So here during this heat exchanging, some particle of water vapor will be condensed out due to the perforated tray type of mechanism, and still some amount of water vapor is not separating during this process, will be separate out in a rectifier by cooling process. We already know that cooling water will condense the water vapor particles. So Now we make sure about that in condenser 0% of water vapor is entering, so there is no problem of choking in a expansion device. Okay, so this is practical aqua ammonia cycle. Now third one cycle and very important type of cycle is electrolux refrigeration system. This cycle is very different from first two cycles, because in this cycle there is no any moving part, means there is no any expansion valve, there is no any reducing valve, or there is no use of we can say pump. So there is no any moving part. This is the main advantage of this cycle. So this type of cycle having a minimum noise creation, or we can say minimum vibration is generating when we are using this type of cycle. Here instead of two, three type of fluid is used. Up to now we already know that water and ammonia is the use, water as a absorbent and ammonia as a refrigerant. Same here, water as a absorbent and ammonia as a refrigerant, but third fluid is added, which is known as a hydrogen. Now hydrogen is the one fluid which is used to increase the evaporation rate of the ammonia, means it is just behaves like a catalyst. Catalyst, you already know that, which is not taking part of in a process, but it will increase the process rate, or we can say increase the process speed. Same thing here. We know that if there is no any type of expansion valve, we cannot reduce the pressure of ammonia. Then we know that in evaporator it is too much difficult to evaporate the ammonia at high pressure. So at the we just starting from evaporator process. Liquid ammonia which is coming out from the condenser, we know that at the condenser outlet high pressure high temperature vapor ammonia is coming out. So it is not a way to evaporate inside the evaporator because its pressure and temperature is high. So first of all, liquid ammonia is entering inside the evaporator, and from another side hydrogen is mixed with it. So hydrogen is work like a catalyst, so it will increase the rate of the evaporation of the ammonia inside the evaporator. So cooling effect is generated in a evaporator, or refrigeration effect is generated in the evaporator. Now mixtures of ammonia and hydrogen is passed to the absorber. Now in absorber water is available. Okay, so water is absorb ammonia vapor only, it will not absorb hydrogen vapor. So here when ammonia and hydrogen gas mixers enter inside the absorber, only ammonia vapor is absorbed inside the water, and vapor is separate out. So hydrogen vapor is further passing to the evaporator, and process is continuously taking place of evaporating. Now strong solution which is coming out from the absorber, which is passed to the generator. In generator there is one generator below one gas burner is provided. So gas burner is providing the heat around 78 to 83 degrees Celsius. So here ammonia vapor which is converted into the high pressure high temperature, which is separate out during this process, and it will be passing through the rectifier. So rectifier is the device which will condense the water vapor if mixed with the ammonia vapor. So only ammonia vapor is passing through the condenser, and condenser is the device which is used to convert the phase, means it will be convert high pressure high temperature vapor ammonia into the high pressure high temperature liquid ammonia. And weak solution which is coming out from the generator, which is passing through the heat exchanger to the absorber, and whole this process is taking place. This cycle having a no any type of moving devices, so its performance is very noiseless as well as vibrationless. So this type of system is not used nowadays because there are so many limitations of these cycles. Second thing is that continuously burner must be provided uh, in generator. So it is one type of difficulty in a household purpose for fire or any other type of problem. So this type of system is not used nowadays. Okay, and last one cycle, which is known as the lithium bromide H2O cycle. This cycle is also one type of vapor absorption refrigeration cycle. Here you can see that two different vessels are available. One is upper vessel and one is lower vessel. Okay, here first of all we are discussing about absorbent and refrigerant. Up to now we see all these three cycles in which ammonia is a refrigerant and water is the absorbent. But here it is somehow different. Lithium bromide is absorbent and H2O means water is a refrigerant. Now due to water is the refrigerant, there is one limitation of this cycle is that we cannot use this cycle below 4 degrees Celsius. So when 4 to 7 or 4 to 9 degrees Celsius of refrigerant effect is required, at that time you can use this type of cycle, otherwise you cannot use this type of cycle. Okay, so here we know that there are two vessels. First is upper one vessels having a higher pressure than atmospheric pressure, and another one is lower vessel which is having a lower pressure than atmospheric pressure. So one vessel is working above atmospheric pressure and second one system which is working below atmospheric pressure. Why this above and below atmospheric pressure is provided in different vessel? In above atmospheric pressure, condenser and generator is provided. So condenser means it is phase converting device, it is always working higher pressure, so it is above higher pressure. As well as generator, which is require less heat provided if it is working on higher pressure. And evaporator and absorber, which is working in a lower pressure. We know that evaporator is always working at lower pressure, but if we put or we maintain low pressure in absorber, then we can easily maintain the lower temperature inside the absorber. Here there is one, I already explained with you, water as a refrigerant, so we have to no, we cannot use this cycle below the 4 degrees Celsius, because at 4.19 degrees Celsius water having a maximum density, and below that temperature or on that temperature water atom will become a steady and it will started to become a ice. So we cannot use below the 4.19 or 4 degrees Celsius temperature. Now here we can see that evaporator and absorber at lower vessel which pressure is below atmospheric, and condenser and generator are available in upper vessel or its pressure is above atmospheric condition. First of all we are discussing from evaporator process. Here 1 minute. Okay, evaporator, there is one spray type of evaporator is available, means water which is coming out from the condenser which is passing through the pressure reducing valve, or we can say expansion valve, so its pressure as well as temperature both will be reduced and it will be passing to the evaporator. In evaporator it will be sprayed on a pipeline. From the pipeline water or any other type of fluid which is passing. Okay, so it will be reduce the temperature of that water or any other type of fluid, and due to heat exchanging is taking place between water and pipeline water or any other fluid which is passing out from the pipeline, evaporation of water is taking place inside the evaporator. Okay, spray water is evaporated. Now this evaporated water vapor is mixed with below water, so sorry, below lithium bromide solution. Here in absorber lithium bromide is available, so when evaporator will generate water vapor, it will be mixed with the lithium bromide. Now this lithium bromide